So we're going to kind of go over the naming rules again. We're going to do a naming flow chart. So remember, the first thing you have to do before you try to name something is figure out, is it ionic or is it covalent? Okay, so is it a metal and a non-metal or polyatomic ion, or is it two non-metals? Okay, so that's really important to be able to identify that. If it's, I'm going to do ionic on this side versus if it's covalent on this side. Okay, if it's ionic, we know that we're going to do the name of the first metal, and then we're going to name the non-metal with an IDE ending. Pretty straightforward, right? The only time we need to add something is, is there a transition metal or a metal that can have multiple charges? Then we need the name plus a Roman numeral, and then the non-metal with an IDE ending. Okay, so remember that Roman numeral equals its charge, not how many of them there are. Roman numeral is the charge. Okay, and then if the other thing we need to check is there is a polyatomic ion. And if there is, we don't change the ending. Don't change the ending. That's it. Okay, just name a polyatomic ion. All right, now if it's covalent, we need to make sure we use prefixes. There is no crisscrossing. You're going to use prefixes and you're going to change the ending to IDE every time. Okay, that's about it. So name these. Remember, use the flow chart, see if you can figure out what kind they are before you name them, and check if you see if you got the right answer. So pause it. It should be fixed on yours, but I noticed I had a typo here. This should have been an SO4. But you should get nickel 2 chloride. That one was a transition metal. Potassium chromate, not a transition metal. Dichlorine monoxide, that one was covalent. Sulfur tetrafluoride, that one was covalent. And ammonium sulfate, this is a polyatomic ion, and this is a polyatomic ion. Okay, so now organic compounds this is a whole other branch of chemistry. You can take organic after this if you're interested. Organic is its own naming system. Of course, it has a different naming system. It used to be that organic things were like living things and inorganic were non-living things. Okay, so that's usually, I know what you and I think of when we think of organic or inorganic. But now it actually essentially means anything that has a carbon base. Okay, so we can actually make these pretty easily today. We used to not be able to synthesize organic compounds. Now we can make almost any organic compound. So today can synthesize easily. Essentially, like I said, they're anything with a carbon base with hydrogen, and then sometimes based on what they're used for, we'll have oxygen, nitrogen, that's an N, phosphorus or sulfur. Okay, so that would be what's considered an organic compound. Inorganic compounds are essentially everything else. We can synthesize them pretty easily, but they decompose not very easily. So that's kind of what we're looking at. So I'm going to talk about organic compounds now, because like I said, they have a little bit of a different naming system. You're not going to have to worry too much about naming until the very end of the semester. But anyway, I just want to introduce you to these because we will be using a lot of these compounds. All right, so carbon. Why do we care about carbon? Carbon is very specific about its bonding. It always wants 4 bonds. Wants 4 bonds. Okay, it's very stable when it's got its 4 bonds. It makes a whole lot of different molecules. Now, it can be 4 single bonds, or it could be 2 double bonds, or it could be a triple bond and a single bond, but it's always going to want to have 4 bonds. So you can have double and triple bonds. We'll talk about how to draw those and stuff later. They also can form straight chains. This is a straight chain. Can form branches, say carbon to a carbon, and they got hydrogens on here, or ring structures. And these are all considered organic. So they can form straight, branched, and ring structures. And you might start to see a pattern in how some of these are named. So this is propane. This branched one is isobutane. Notice it has a different number of carbons. And cyclohexane, anything that's in a circle is going to be a cyclo. Okay, now they can also, I mentioned double and triple bonds. So this thing has a double bond. So see, each carbon still has 4 bonds. The double bond counts as 2 bonds. You can have a triple bond. So this is ethene. This is ethylene, or sorry, ethine. Ethylene, I had ethylene on the mind. So ethene, ethine. This is acetic acid. This is organic, carbon, oxygen, hydrogen. Hey, these are some really common molecules that you guys are going to see. So if I say ethene, you should probably be able to picture what that looks like. So all compounds can be classified as either inorganic or organic. In organic, we kind of have two subsections. There's hydrocarbons. If you break that word down, it's hydrogen and carbon. So anything that's only hydrogen and carbon is a hydrocarbon. There's also functionalized hydrocarbons, and those have things attached to them. They have functional groups with functional groups. So if something has a functional group, then that means it can do some other things. So they have different functions. So we're going to talk about what functional groups are as well. So some really common hydrocarbons are on this list here. I got methane, propane, butane. Notice these all have an ane at the end. They have all straight structures. And pentane. And then ethene has a double bond. Ethine has a triple bond. These are all really useful things, okay? So I actually want to talk about the prefixes here really quick. So they actually tell you something. Anytime it's just one carbon, it's going to have a prefix of meth something. It could be methane, could be methene, or methane's not a thing. A methyl group means it has one carbon in it. Two carbons, the prefix is eth something. 3 carbons is prop. So propane has 3 carbons in it. You can see it right here. 4 carbons is bute. So butane has 4 carbons. 5 carbons is pent. And like the rest, 5 and up are exactly what you would expect. Hex, het, oct, all of those. It's really just the first 4 that are a little weird. Okay. I do have a mnemonic for these. The way I remember these is Mary eats peanut butter. MEPB. That's how I remember them. So anyway, however many carbons they have actually affects what their name is going to be. Okay, so you might have noticed that the first ones that don't have any double or triple bonds end in ane, A-N-E. Those are actually called alkanes. Okay, this is when they are all carbon, single bonds. Okay, they have a generic formula. It's always going to be like however many carbons there are. So CN. H, it's going to be 2N plus 2. So if I have 2 carbons, then that means I'm going to have 2 times 2 plus 2 hydrogens. So it would be 6, C2H6. So you can actually predict the formula of any size of alkane. All right. Another word for these is saturated hydrocarbons. Saturated hydrocarbons. That just means it doesn't have any double or triple bonds. It has as many hydrogens as it possibly can bonded to all of those carbons. And they can be straight chains, or they can be branched, okay, all considered alkanes. Which brings us to cycloalkanes. So that's an alkane that has been turned into a circle, or the chain reconnects to itself. Chain reconnects to itself. Okay, now in order to do this, to keep all of our 4 bonds on carbon, it's actually going to lose 2 hydrogens. So its generic formula is going to be CnH2n. So you can predict the formula of a cycloalkane. Okay, and then that brings us to alkenes. Anything that ends in ENE, these ones have a double bond. Have a double bond. Okay, these would be considered, instead of saturated, they are unsaturated hydrocarbons. And that's just because it doesn't have as many hydrogens as it could possibly have. And so I could add more hydrogens and break some of those double bonds. So anytime you have a double or triple bond, it's called unsaturated. So we're talking about saturated fats and unsaturated fats. Unsaturated fats have double bonds. Saturated fats don't have any double bonds. Okay. Something that's special about alkenes is that they can make what are called cis and trans isomers. Can make cis and trans isomers. So there's a couple words here we need to talk about. Isomers, first of all, means things that have the same formula but are put together differently. Okay, so I got cis-2-butene here and trans-2-butene. These have the exact same formula, but if you notice, my hydrogens are on the same side, and these CH3 groups, which are methyl groups, are on the same side. And they're just kind of switched on this one. My methyl groups are on opposite sides and my hydrogens are on opposite sides. So if they are on the same side, it's cis, same side. And if those groups are on opposite sides, then it's going to be a trans group. Excuse me. So it's going to be a trans isomer. Okay, so that's what those mean. All right, so those are some of the main types. The last thing I want to talk about are functional groups. And that's groups that are put onto hydrocarbons to make them have other functions, do other things. So groups can add, and I say different functions because the name is functional group, but really what I mean is they react differently. So groups can add reactivity. You could add a carbon group because these aren't listed on this chart under here. But carbon groups are like a CH3 group, which is called a methyl group because it has one carbon. A CH2CH3 group is an ethyl group because it has two carbons. Okay, so there's some carbon groups you can add, or you can add things that are not carbon groups, and those are all listed on here. Okay, so functional groups are essentially things that you can add on to give different functionalities. We already talked about alkenes. Alkynes are things with triple bonds. Alcohols are things with OHs on them. Haloalkanes are things that have halogens on them. Amines are things with nitrogen in them. Aldehydes have a double bonded oxygen on the end specifically. Ketones have a double bonded oxygen in the middle of the compound. Carboxylic acids have a double bonded O and an OH. So it's like an alcohol, but it also has a double bonded O. Esters have a double bonded O and a single bonded O in the middle of a compound, not on the end. And amides have a double bonded O and a nitrogen, or amines. So these are kind of different functional groups. They give different things structures and functionality. And that's going to be really important when we get to like organic and biochemistry, which is really a topic for 162. So you guys are just going to see some of these molecules, and that's why I wanted to introduce them to you.